everybody, and welcome to this video on trig equations. In this video, we have a look at how to solve for the angle in a trig equation. So I've broken this up into two steps. The first step is make the trig ratio the subject of the equation. So your trig ratio is either going to be sine, cos, or tan, and you could also be working with the other trig functions, cot, cosec, and sec, but more often than not, we work with sine, cos, and tan. So we make those the subject of the equation, and then we use the inverse trig ratio on both sides. So the inverse trig ratio is just the inverse, like how adding is the inverse of subtraction, and it helps us reverse that. So the inverse trig ratio allows us to do that. It is a button that you'll press on your calculator, so don't stress out too much about it. So here we have an example. We have sine theta is equal to x. And if we would like to make theta the subject, the angle, then we're going to apply the inverse function, which is denoted by this -1. So the inverse function of sine is sine to the power of -1 on that sine of theta. And because it is an equation, what we do on one side, we also do on the other side. And then what happens is that the inverse function and the trig function cancel out with each other, leaving you just with a theta. And on this side, we have sine to the power of -1x, which is the inverse function, which we can then use the calculator to solve. So this year we only get one angle. So we spoke about the trig function, and what makes it different from normal equations is that the answer is repetitive. So to get all of the repetitions, we're going to have to apply the general solution, which we will look at in the next video. So this video is just about getting the angle. So let us have a look at an example. Okay, so here are some examples. So the first one is cos theta is equal to 1/2. So we're going to apply the inverse function to both sides. So we have that cos, that's the inverse function of cos theta, is equal to the inverse function of 1/2. So we've applied the inverse function on both sides. The inverse function and cos cancel out, leaving us with just theta is equal to cos to the power of -1.5. And then we just type that into our calculator and we get that it is 60 degrees. Let us do the same thing for number 2. Now in this case, our trig ratio is not by itself. So here we have our trig ratio, and it's not by itself. So we're going to divide both sides by 3 to get the trig ratio by itself. So that's 8/3. And then what we're going to have is then we're going to apply the inverse function. So we have sine -1, and sine theta is equal to sine -1 to the power of 8/3. Okay, so then theta is equal to sine to the power of -1/8/3. And in this case, we have no solution. Because if you think of a sine graph, a normal sine graph, its range is between -1 and 1. And 8/3 is greater than 1, so there is no sine graph, so we won't get an answer. Let us have a look at the next one. So here we have tan x plus 10 is equal to 2. Okay, so first we're going to make tan the subject. Please note that this whole thing here is the trig ratio, so we can't separate the 10 at the moment. So first we divide both sides by 3 and we get tan theta plus 10 is equal to 2/3. Then we apply our inverse function, so tan theta plus 10 is equal to our inverse function of tan over 2/3, and then the tan and the inverse function cancel out, leaving us with the angle, which is theta plus 10 is equal to tan inverse 2/3. Now typing that into the calculator, tan inverse of 2 over 3 is equal to, rounded off to 2 decimal places, 33.69 degrees. Now we can solve by theta by taking the 10 over, and when we take it over, we change the sign, so this becomes 23.69 degrees. Okay, so they're getting more and more complicated. Let us have a look at the last one. Again, we want to get the trig ratio by itself, so that's that. And the angle, remember, we can't change it at the moment. So we first get the ratio by itself. So we take the 4 over, so this here is 8 cos 2 theta is equal to minus 6 plus 4, which is minus 2. And then we divide both sides by 8. So then we get that it's equal to minus a quarter. Okay, so what we then do is we take the inverse function of both sides. So we have cos of minus 1 of cos 2 theta is equal to cos of minus 1 of minus a quarter. And then what we get is 2 theta is equal to, and the inverse function of minus a quarter is 104.48 degrees, rounded off to 2 decimal places, and we finally divide by 2 to get theta by itself, and we get that theta is equal to 52.24 degrees. Please make sure that you've understood these examples. So start with number 1 and make sure that it makes sense and you understand each of the next additions to the difficulty. Please watch our next video on how to then get the general solution of cos graph.